Hi, this is Victor Morganti from FactEngine. Today we're going to be looking at reverse engineering inside the Boston Conceptual Modeling software and starting to write queries in FactEngine inside Boston. So we've got in front of us the Boston Conceptual Modeling software, and we've got a model in the Model Explorer, customer invoices. I've set this up. It's an empty model, and reverse engineering requires a model that doesn't have any elements in it yet. So we go to model configuration for that model. Now, this particular database we're going to reverse engineer is an SQLite database. So we'll just select that database and we can test the connection. Let's apply that. Go to reverse engineering and click on reverse engineer database. Now we do have to wait a little bit patiently while Boston goes away and reverse engineers that database. So it keeps you informed of where it's at in the process along the way, and it depends on how big the database is for how long it's going to take to complete the process. So this is going to create your object role models, entity relationship diagrams and property graph schema for your database. So that's finished now, it's complete. Let's hit OK. And let's create a page in the language entity relationship diagram inside that model. And open that page, and we can see that the various entities are already created for us. Let's drag those onto the page. So a customer has an account with financial transactions, which are for invoices that have invoice line items, and a customer places orders which have order items which are for products in various product categories. So Boston's gone away and reverse engineered that database for us, and that's its schema. Now we can almost immediately go away to FactEngine and start querying that database, but first we've got to do a little bit of housekeeping to make our results meaningful. So let's go to customer and say morph to ORM diagram and create an ORM diagram for customer, and then click on the entity type for customer, and we'll add all the associated fact types. And we can see that a customer has a first name, a middle name and a last name. If we want those in our results as a unique identifier for our customers, we need to give that a external uniqueness constraint. So let's do that. So we're uniquely identifying customers not only by their customer ID but by their first name, middle name and last name. Let's also do that for products. If I go down to product and I morph to ORM diagram and create an ORM diagram for that entity. Click on the entity type, add all the associated fact types, and I'll just drag that out so you can see what I'm doing. Now it's a many to one relationship. We're going to set that up as a one-to-one. That sets it up as a unique key for that particular entity type or a unique identifier, and we're ready to go. So we can go back to the model in the Model Explorer, go to FactEngine, and we should be able to say which customer made an order that has which product, and hit go on that. That didn't work. We haven't set up a, let's try has. So which customer has an order that has which product, and it's come back and given that for us. So Merle Shanahan bought a hard drive. What's interesting about that query is that it's used something that's quite unique to FactEngine is that an order has order items, and an order item is for a product, but we've said which customer has orders that have that product. FactEngine's been smart enough to realize that because the only path from order to product, there is only one path, then we're heuristically saying that the order has that product. So if we look at the query again, which customer has an order that has which product? So thank you very much. That's reverse engineering in Boston and using FactEngine to query the database. I hope you enjoyed the video. If you like the video, please like and subscribe, and I'll see you in the next video.